So we will continue with displacement and distance. So we will first so distance, as I said, if you start from point A over here and you have to reach this point B over here, then if you are following this particular path like this, then the distance is the path traversed by the body from A to B. So because the distance is the path traversed from A to B, you are following a particular path, and since it is a particular path, hence you do not need a direction. Now since it does not need a direction, that's why distance, that is distance, is a scalar quantity. This is a scalar quantity because it is following a path which does not require a direction. Distance is measured in meters. So meter is the SI unit of distance, and normally it is denoted by the letter small s. Small s is denoting the distance in physics. So in physics, when you say small s, it normally means distance. Now, the other part of distance is something wherein you need to understand it this way, that if I am able to travel from A to B directly without going through a particular path, then what would happen is that it will be the shortest distance between the initial point and the final point. So the shortest distance which is there from the initial position to the final position is called as displacement. Over here you can see that when I say, like for example, if the distance was over here 100 meters and the displacement over here is 80 meters, in case of distance, I need not tell that in which direction you have to follow because it is following a particular path. But in displacement, I cannot say that A and B is 80 meters apart. So if it is not possible that if I tell a person who is standing at A that go 80 meters and you will reach point B, because it is the shortest distance and you don't know whether to go in the north direction or south direction or east, west, wherever it is. So because you don't know that what will be the direction, hence displacement becomes a vector quantity wherein it is necessary for you to tell that in which direction that person needs to travel so that he reaches the destination B. Accordingly, displacement is a vector quantity, again measured in meters, and it is denoted by S also, but only thing is that it will normally be given as S and an arrow above. So an S and an arrow above is displacement, whereas S alone will be distance. Very few times we are going to differentiate as distance and displacement. Otherwise, normally S will be said to be as distance or displacement in most of the questions which we'll be learning in the later part of the 9th standard. So over here we see that distance and displacement can be defined as follows. Distance is the total length of the path. Okay, distance is the total length of the path through which a body moves. So it is called the distance traveled by it. The distance traveled by a body depends upon the path it follows. So it is going to be dependent on the path it follows. Hence we have the distance as the path traversed by the body. Whereas the displacement is the shortest distance between the initial position and the final position of the body. Now that particular distance is the magnitude of displacement, whereas the direction is the point from initial to final. So over here, from A to B, when I am taking from A to B, the distance between A and B, the shortest distance is the displacement, whereas the direction of the displacement is from A towards B. So we have the definition as the shortest distance from the initial position to the final position of the body is the magnitude of the displacement, and its direction is from the initial position to final position. Now, why is it important to say initial position to final position? Why? Because let's consider if person is at A and is going from A to B. If I consider that this is my north direction, so this will be my east and this will be my west. So this position from A to B will be automatically northeast. Whereas if somebody is at point B and he wants to come over here, then he will needs to travel over here with southwest. Hence, the displacement from A to B is in the northeast direction, whereas the displacement from B to A is not northwest, but it will be southwest, which is opposite of that. That's the reason the direction is very important in case of displacement. So accordingly, we have this particular differentiation given in the textbook for the distance and displacement. First is, it is the length of the path traversed by the object in a certain time, that is distance, whereas it is the distance traveled by object in a specified direction in a certain time, distance between the final and the initial position, that is displacement. Distance is a scalar quantity, as it only has the units, as the magnitude and the units, whereas displacement is a vector quantity because it goes magnitude, units and the direction. Distance depends on the path what it is following, so it is depending on the path followed by the object, where displacement does not depend on the path followed by the object, it is the shortest distance. Distance is always positive. Okay, distance can never be negative or zero. It can be zero, but it can never be negative. So distance is always positive, and that's the reason it is scalar quantity. Whereas displacement can be positive or negative depending upon the direction in which it is traveling. So if I consider that the body traveled from A to north over here, and then it came back over here and went to here, which is point B, then you can see the resultant is negative some meters. Why is it so? Because the initial position in which it moved was positive, so when it returned in the opposite direction, it will be negative. Hence, the displacement can be positive or negative. The next is, it can be more or equal to the magnitude of displacement. Now, distance can be equal to or it could be more than the magnitude of the displacement. Very simple. If distance is such that the traveling path is exactly the shortest distance, then automatically what happens is the distance and displacement will be same. Whereas in this case, if it is this way, the distance can be greater than the displacement. Similarly, in the next part for displacement, its magnitude can be less than or equal to the distance, but never greater than the distance. Because displacement is the shortest distance, therefore displacement can never be greater than the distance. It can be equal to it or less than it, but can never be greater than that. The last and final thing is distance. It may not be zero even if the displacement is zero. Even if displacement is zero, distance may not be zero. Okay. But if distance is zero, then displacement is surely zero. Okay. So that's why distance may be zero even if displacement is not zero, but it cannot be zero if displacement is not zero. Whereas displacement, it is zero if distance is zero. If distance is zero, there cannot be any displacement at all. That's why if distance is zero, displacement is zero. But it can be zero even if displacement is not zero. See, this is because suppose we take a circular path. When you take a circular path, a particular thing is starting from here. It is going around and coming back to this particular position. So you can see the distance what it has traveled is the circular path over here like this, which is equal to the circumference of this circle. So distance is equal to the circumference. But what is the initial position? This point. What is the final position? This point. So accordingly what happens is that the total displacement traveled by the body in the end of the circle is zero. Hence the displacement can be zero even if the distance is not zero. Okay, so that was about distance and displacement.